today, right now, you have more power at your fingertips than entire generations that came before you. Think about that. That's what technology really is. It's possibility, it's adaptability, it's capability. But in the end, it's only a tool. What's a hammer without a person who swings it? It's not about what technology can do, it's about what you can do with it. You're the voice, and it's the microphone. When you're the artist, it's the paintbrush. We are living in the future we always dreamed of. We have mixed reality that changes how we see the world, and AI empowering us to change the world we see. You have more power at your fingertips than entire generations that came before you. So here's the question: what will you do with it?
Please welcome to the stage Corporate Vice President of Azure Data, Rohan Kumar.
Thank you. Hello and welcome, everyone. My name is Rohan Kumar, and I'm the Corporate Vice President of the Azure Data business at Microsoft. Thank you all for joining me here today. As you saw in the video, it's an incredibly exciting time for all of us in the tech industry. We have more power at our fingertips than ever before. We also know that the world is changing more rapidly than ever before. With that, a key question is, how will you leverage these incredibly amazing capabilities at your fingertips to help your companies digitally transform so that they're able to adapt and stay ahead of the curve in the future, given the pace at which innovation and change are happening? You know, there are multiple ways of thinking about digital transformation, but we have a very clear point of view of what it means based on the experience we've gained at Microsoft. We classify digital transformations very specifically into these 4 pillars that you see on the slide. The first one is really about empowering your employees with the state-of-the-art tools so that they can be the best in their job. The second one is about deeply engaging with your customers with new and innovative ways. The third is really about building new and better products that satisfy what your customers need. And finally, the fourth pillar of digital transformation is really about transforming your operations so you're able to be a lot more agile and efficient than what you are today while cutting costs. You know, at Microsoft, as we went through our own journey of digital transformation, there's a few things that we realized as we started making it a lot more concrete based on the frame that I just described. And as we are going through that, we created this concept called the digital feedback loop, which I believe applies equally to any enterprise that's going through a digital transformation. So what are the characteristics of a digital feedback loop? The first one is really about getting a lot of information signals from various aspects of the business and having the ability to actually capture those signals in real time. The second capability of the digital feedback loop is really about synthesizing all those signals that you're getting from the various aspects of the business and generating meaningful insights from them. And finally, the third and the most critical capability of the digital feedback loop is the ability to make intelligent decisions based on the insights that you just gain, and the ability to feed those decisions back into the business processes. So when you think about characteristics like employee input or product telemetry coming out of your products, customer feedback, or operational data coming out of your DevOps systems, all these combined will help you generate insights that make you make intelligent decisions. And that really is the basis of digital transformation that we've seen at Microsoft. Now let's take a look at a few of our customers who are actually successfully navigating this change. The first one is eSmart Systems. They have totally revolutionized the power grid industry. They've deployed a solution based on connected drones that leverages deep learning models at the edge to do image classification that helps them do predictive maintenance. So something which actually required humans to go into remote and often dangerous areas is now being done remotely with the help of drones. right? This has not only increased the security, I mean, now their employees essentially a lot more secure because they're not going into these hard-to-reach, dangerous areas, but they're also saving a lot of time and getting that focused on fixing issues when they happen rather than trying to discover them. Their productivity and efficiency has significantly improved. ASOS is a trailblazer when it comes to e-commerce, online e-commerce, right? They completely revamped their commerce platform based on the microservices architecture, which now enables them to do real-time personalization. So they have about 15 million and growing customer base across the world, and they are leveraging this new e-commerce platform to deeply engage with them in real time and give, based on the data that they're getting from their customer engagements, they're able to give them, show them the products that they desire. It's fundamentally transformational. Now you look at Walmart. Walmart is making a big bet on the cloud, and one of the key reasons they're doing that is to significantly improve and streamline their operations. They've built an analytics platform on the cloud that helps them in real time to get insights into their sales data, into the customer sentiment, and the inventory status. This analytics platform, they're able to leverage and share with their suppliers so they learn from these insights and serve their customers better and manage their inventory better. For a business of this scale, we are talking about hundreds and millions to the tune of billions of dollars. It's pretty amazing to see what's happening. And finally, in the category of transforming products, DocuSign has revolutionized how transactions and contracts get signed. Based on the online transaction platform that they've built, they've essentially removed the need to actually deal with paper, filing cabinets, fax machines, etc. 50% of their transactions complete within the hour, and about 80% of them complete within the day. Now just think about it. In a lot of scenarios, things that would take days, weeks, or even months is being transformed in a very foundational way. These are a few examples of customers who are essentially going through their digital transformation based on the feedback loop frame that I just described. Now, as you listen to these stories, one thing that becomes abundantly clear is that the core of the digital transformation that these companies, our customers, are going through, the very foundation of the heart of it is data and AI. You know, the amount of data that's getting produced in the world is basically just gone off the charts. Every time I tweet, every time I go to a website, every time I actually walk into a store these days, every time I use any connected application or a service, data about me and my usage and my pattern gets produced. Imagine the ability to basically use the insights that come out of this high volume of data across your entire customer base. That becomes the basis of going through digital transformations. Now, one of the things that becomes pretty apparent is since data and AI are the foundation, to go through any such digital transformation, you need to bet on a modern data estate. And as we've been on this journey building a modern data estate for our customers for the past 8 or 9 years, this is the advent of the cloud and the hybrid models, we've deeply engaged with our customers, and the scenarios that our customers are thinking about very specifically fall into these 4 categories. The first one is modernizing their data platform on premises. There are several reasons why, for a lot of our customers, a certain category of applications are not ready to move to the public cloud yet. They are looking into continuing the investments that they've made on premises and gain from them. Several of our customers are looking into migrating to the PaaS services in the cloud, which we call the modernize to the cloud category, to save costs and leverage the rich benefits that we get out of the intelligent platforms that are built on these PaaS services. The third category is really about building what I call cloud-native applications. These applications just weren't possible before, and the only place you can truly build them at global scale is in the cloud, and leveraging these applications to create completely new experiences for their customers. And finally, the pillar is around unlocking insights. Whether it's data remains on-prem or sort of moves to the cloud, the ability to sort of reason over your entire data set to generate insights. And one key element, as I called out before, is this, as we think about our product strategy, is this notion of hybrid. Look, what we very fundamentally believe is for the next foreseeable future, whether it's 5 years, 10 years, 15 years, whatever, we are going to live in the hybrid world. Our enterprise customers have invested lots and lots of money in building up their on-premise data centers. They understand the value of moving to the cloud, but what they're looking for is somebody to partner with who can actually engage with them where they are and actually get them along on this journey. So for us, from a product strategy standpoint, investing in hybrid, every capability that we add essentially is available independent of where you choose to run your application. That is very key. And finally, across all these scenarios that our customers are going through, even if it is just modernizing the database on premises or moving to the cloud, a key element is how do you convert even the legacy applications or the investments they've already made into intelligent ones. And this is why, for us, AI is a core part of our data platform. We don't think of AI as being something separate. It's really ingrained into how we think about data estate modernization. Now, with that as a background, let me sort of go and talk about the innovations that we're doing in each of those 4 key pillars that I spoke about. The modernizing on-premises. SQL Server, which is a flagship database that we have, it's the most highly used commercial database that we have in the world, has an amazing track record of innovation based on what we've learned for our customers in service of our customers. We've innovated in the core query processing, core storage scenarios. We've innovated in security. More recently, we've expanded our reach to be cross-platform, where we support Linux, Docker, Kubernetes, et cetera. We've also innovated over the last couple of releases in bringing intelligence and AI closer to the data that is inside the database, so you don't have to move the data around. So there's been a ton of innovation that's gone in. And I'm really excited to announce that with SQL Server 2019, which Scott spoke about this morning, we're taking a huge step forwards in managing your entire data estate. So what do I mean by that? Of course, we support Windows, we support Linux, we support Docker. We're expanding our reach with Kubernetes to support mission-critical applications in containers. We're partnering very closely with Red Hat to serve their container images as well. But the thing that I'm most excited about with SQL Server 2019 is the support for Apache Spark and HDFS. This is really groundbreaking in terms of the way we are going with this. When you think about several of the big data systems, HDFS has become the de facto standard where the data is being stored, and Spark has essentially become the de facto compute engine that's used to manage that data. Now, imagine a world where your SQL Server, the entire tooling ecosystem around it, natively understands the data that's stored in HDFS. When you think about the Parquet format, CSV, et cetera. And Spark, of course, is already able to leverage that and building a lot of these things together and seamlessly. Very, very exciting. So how does SQL Server 2019 enable intelligence over all your data? One of the first things we are doing is extending the vision that we had with Polybase to reach out to several of the other data stores that are very popular on premises and in the cloud. So you can leverage SQL Server as the hub for your intelligence and all the tooling that's built around it. The next thing, as I just said, is being able to leverage Spark and HDFS to manage all your data. And by the way, this doesn't mean that you actually have to sort of give up on your existing data lake and move to SQL Server. We sort of put ourselves in the shoes of the customer and said, how can you use SQL Server, where SQL can actually seamlessly integrate, even with your existing data lake, to solve some of the challenges that we see our customers going today. While these big data systems are great in terms of managing data, when it comes to things like warehousing, BI reporting, when you want to do the end-of-quarter close, there's a lot of friction that comes in where your traditional relational databases still are the solution of choice. Now, imagine a world where that sort of seamless integration removes every friction that you've seen. Super amazing. And finally, continuing the innovation that we had with R and Python, we have effectively extended SQL Server for you to run any custom language of your choice. So we've added support for Julia and Java, but you can extend it to the language that you want. And one of the other things I'm super excited about is the announcement that Azure Data Studio is a new tool that we're releasing as a part of the SQL Server 2019 announcement. It's a tool that essentially allows you to manage all your data assets, be it data on-prem and in Azure, in relational systems, structured data, unstructured data, big data, using a single tool, which is contextually aware. It's very, very exciting. Again, this is based on a ton of feedback that we've heard from our customers. in terms of leveraging a single tool and a unified experience. So one of the examples is if you're a data scientist who's used to a notebooks experience to sort of create and train models, you can use Azure Data Studio to do that. If you're a data engineer who's used to T-SQL and who wants to run T-SQL queries against data that's stored in HDFS, you can do that too. It's a single tool that essentially allows you to do all of these things. Getting into a little bit of the specifics of how SQL Server 2019 enables you to do this. You basically have, conceptually, the way to think about it is SQL Server and Spark running on every data node that connects to HDFS. We've modified the SQL engine to natively understand like I said, the big data formats when you think about Parquet, et cetera. There is a notion of compute pools for both SQL and Spark that you can create, and depending on the familiarity that of tooling that you have, you can choose to use whichever set of APIs that you want. We basically have natively integrated this with Kubernetes that allows you to scale out your storage layer and your compute layer almost independently. You can have a single node that works over a scale out of your HDFS cluster, or multiple nodes depending on the power that you want to give. It's pretty amazing. You can basically create an external table that allows you to join the data that's stored in any of these big data systems in an extremely performant and functional way with the data, the high-value data that you stored inside SQL Server. So again, it's pretty amazing to see Spark and SQL Server working together on big data, on data that's stored in your relational databases. You're able to join them, give interesting queries out, leverage the insights, and go ahead with the business. Again, super exciting how this is coming together. The best way to sort of actually see how SQL Server 2019 is helping is to listen to a customer story. And I'm really excited to invite Gerard from Johns Hopkins University to come on stage and join me. Hi, Gerard. Thank you for being here. So, Gerard, tell us about your work at Johns Hopkins.
At Johns Hopkins, what we're trying to do is to democratize data. We want scientists who have large data sets and who want to share it with the world. We want to help them and make it simple for them. On the image you see there, on the left side, you see a galaxy. This was a picture taken with during an astronomical program called the Sloan Digital Sky Survey, and it is one of 300 million such galaxies. The thing on the right that you see, that's basically a map of the local universe where you see points that correspond to these galaxies. What this Sloan Digital Sky Survey did was they put this map of the universe in a database and made it accessible to the whole world using a simple web interface, and people were allowed to write custom queries to it. And this became very popular. So popular that we actually have expanded it to other data sets, one of which is that I have done, and what I'll talk a bit more about, is simulations, cosmological simulations.
Perfect. So what are cosmological simulations used for?
So to understand the complex structure of the universe like this, we cannot do this with pen and paper and some models. Instead, we run cosmological simulations, which are basically virtual universes that we build in a supercomputer, and that we evolve forward in time using models of the rather complex physics that is going on. So the one that you see right now is an example of such a simulation, the one that we actually stored in a database. You see the same kind of web-like structure. It's called a cosmic web generally, with all kinds of little dots in there that are ultimately clusters. And what we did is we used clustering algorithms to get those clusters out of the 10 billion particle simulations and stored those in a database, and again made that available to the world as well, which again made this particular simulation one of the most detailed studied one of its kind.
Perfect. So how will SQL Server 2019 help you with your work and what you just described?
Well, as you saw there, and if you see now, the data is getting so complex, and we see phenomena that are so interesting and so complex, but they are no longer concentrated on these little dots. And so what we need is, instead of having a database that only has rows, one row per cluster, people need to get access to the raw underlying data to see all these beautiful fuzzy structures of exploding stars, etc. That data is too large for us to store in a traditional database system. And so instead, we want to leave it in files. And SQL 2019 seems to be perfect for this. No, we can load it in HDFS, we can map it there as if it is a table, we can still have the high-value cluster data or Galaxy data so that we can write queries across this. And so our end users will suddenly, without them having to know anything else but SQL, get access to the complete data of this.
Yeah, perfect.
The simulation.
That's very exciting. Thank you so much, Jared, for sharing your thoughts. It's a great example of how the innovations that we've done in SQL Server 2019 is able to help users of SQL Server manage their entire data estate. Now, what better way of actually looking at the innovations that we've done than with a demo? Please let me invite Nelly on stage to come and showcase using Azure Data Studio. Nelly?
Thank you. All right. Let's start with the administration portal for our SQL Server 2019 Big Data cluster. This is showing us an overview of the cluster that we have deployed. Now, as you can see, our cluster has 100 storage pool pods containing HDFS, Apache Spark, and SQL Server all running. The tool that we will use to interact with the data in our cluster is Azure Data Studio. Here, we can easily get a unified view of the data that's sitting in our SQL Server master tables, as well as the data that's sitting in HDFS in our data lake. As you can see here, these are the simulation files that we have received from the Johns Hopkins University, containing the raw data. What we have done is that we have transformed these into a Parquet format so that we can more easily query them both from SQL Server and from Spark. Now, let's take a look at this data. Azure Data Studio also has a built-in notebook experience where you can do analytics using Spark. As you can see here, I have a notebook open, and in my first cell, you see that I have a Python script that's basically submitting a Spark job that's loading millions of rows into the in-memory data frame that I have here. Now, let's take a look at the data. The data that we will see is the particle positions at a specific point in time. And it's also representing their velocity, as you can see down here, in each direction. Now we can use popular libraries like matplotlib and Python to visualize this, like we're doing right here. Here, we're plotting the particle positions. And this can, for example, help scientists to study dark matter halos, or even identify specific regions that they want to dig deeper into and study. Now, normally, when you're working with big data, this is done in an automated way at scale, using, for example, Spark ML. And the results can then be summarized and put into a high-value store like SQL Server to make them available for end users to query. Now, let's take a look at the summarized data that we have loaded into the SQL Server master instance in a table. Here's our table. Now, as you might have noticed, I didn't really have to switch any tool to access my data in SQL Server. So in this unified way, I can access everything that I need in my cluster across engines and storages. As I'm now connected to my master instance, we have this table here. And to be able to join the summarized data now that I have with the data that's sitting in my data lake in HDFS, I will first need to create an external table. So let's create a query here. So this T-SQL script is going to create my external table called millennium particles. Very hard to say. Now, in SQL Server 2019, we've actually added the ability to natively from the SQL Server engine read and write Parquet and CSV files. Now, what's happening here is that it's the SQL Server engine that's doing this is actually sitting in our data lake, right where the data lives. So there's no data movement when I'm querying over my external table that's pointing to the data source that you see here, that is my data lake. Let's create our external table so that we can proceed and join this data with our data in the data lake. Now it's time for the join. Are you guys ready? All right, so you might have noticed that this join pretty much looks like any other query or join that you would do in SQL Server, right? Well, that's actually the whole point. There's really nothing different to query over your data lake than querying any other SQL Server table. This data can now be consumed by all the applications and dashboards that are running on top of SQL Server. And let me show you an example of that here. Here's a Power BI dashboard that is basically showing you, similar to the plot that you were seeing earlier in our notebook, another representation of a snapshot on when the universe was formed. For Johns Hopkins University, this means that without a single change in their end-user application, they can now share this raw simulation data with scientists across the world, and who knows, maybe even help unlock some of our mysteries in the universe. Thank you.
Thank you so much. Well, there you go. With no app changes, you're able to access data that's stored inside the data lake. That's really, really exciting. Now, there's a lot more innovation that I didn't speak about that's coming in SQL Server 2019. You see a glimpse of a lot of the work that we're doing, just across the board from security, and we'll speak more about these in the days to come, but I really encourage you to download the CTP of SQL Server 2019 today. Use it. We've loved the feedback from the community. You've helped us build a great product for the last 25 plus years, and let's continue that. Thank you. Moving on to the next theme that we've heard from our customers, this is just around modernizing their existing applications to the cloud with the initial investment of doing that to save costs. We have a whole range of operational database services that we have in Azure, both from SQL DB for managing SQL stuff, for multi-model NoSQL with Cosmos DB. You've heard about that. We've launched open source database support with MySQL and Postgres earlier this year. They're generally available, and we're seeing significant adoption of those from our customers. And today, I'm very excited to announce the public preview of MariaDB, which is another open source database that is extremely popular and gaining a ton of momentum on the same fabric that we have the other OSS database services. On the SQL DB side, there are a couple of announcements which I'm very excited about. The first one is the general availability of the general purpose tier of SQL database managed instance. This is really exciting, and this has been an amazing journey over the last year and a half, working with lots of customers like yourselves in fine-tuning. We really wanted to ensure that when we meant compatibility, we sort of got that right. And it's an exciting day, just based on the feedback we received to make this generally available. So what is Azure SQL Database Managed Instance? It's basically a capability, a PaaS service deployment model you have in Azure SQL Database that allows you to lift and modernize your existing application with no app changes. This was something that we heard from our customers loud and clear as they were looking into modernize their existing applications to the cloud. While they loved the benefits that a PaaS service would give them, the cost of doing the migration was equally important because that was causing a ton of friction. So going in, a fundamental requirement that we had with managed instance was to have no app changes. Security and compliance was a very, very key design point, all the way from supporting the VNet configuration that exists on-prem for governance and compliance reasons, to features like always encrypted, to features like threat detection, which are marquee features in Azure SQL Database. We're really focused on making them work with managed instances as well. And finally, competitive TCO. This is another big thing that we'd heard from our customers, where we want to make sure that price wasn't the reason that was causing friction for them. with the Azure Hybrid benefit that we've already launched, and the support for reserved instances that you get with Azure SQL Database, you can get up to 80% savings when you migrate your existing applications to the cloud. This is really amazing, and I've said this in the past in the discussions that we've had. With the product capability that we have with managed instance and the work that we've done around security and compliance to ensure that all the compliance bar that you have in your enterprises maintains when you move to the cloud, and with the business model that we've defined around Azure Hybrid benefit and reserved instances, there is absolutely no reason to go anywhere else with your SQL Server applications. Azure with SQL DB MI and the work that we've done around getting the database migration service, which we made generally available a couple of months ago, is the perfect destination. Azure is the perfect destination for all your SQL Server workloads. It's really great. The other thing I'm very, very excited to announce is a feature or a capability called Hyperscale. Again, it's another deployment option that we've added to Azure SQL Database. So what is it? We've been on this cloud journey for about 8 years. One of the things that has become very, very clear as we've had discussions with our customers is they're looking into migrate some of the largest mission-critical applications, be it in terms of size or the usage, onto the cloud. The question that gets asked is, usually when you think about the kind of infrastructure they use on-prem to run these, they're investing in humongous machines. And if cloud's built on commodity hardware, how do you make this happen? We actually had to reimagine the entire storage architecture of SQL Server. With Hyperscale, we've basically separated out and rewritten our storage and recovery layer of Azure SQL Database to be inherently scaled out by design, which effectively means that theoretically there is no limit to the size of the database that we can support with Azure SQL Database. We've tested it up to 100 terabytes, and you'll very shortly see in this demo, what amazing technology innovation this is, where you can auto-scale up to 100 terabytes. You can do point-in-time restore in constant time over a very, very large database. And the ability to be able to scale out compute and storage, even for your operational database independently, is groundbreaking. So we're very excited about this. This is something that the core SQL Engine team has been working on for the last 2.5 years, and very excited to announce the public preview of that. And what better way to know about MI and Hyperscale than, again, invite a customer on stage. Let me invite John, who's the general manager at Komatsu, to please join me on stage. Hi, John. Thank you so much for being here.
Great to be here.
Can you give us a little background and overview of the journey with AI you've been with at Komatsu?
Yeah, sure. So like many organizations, we've got lots of different sources of data. And for example, we have our ERP, which in our case is Microsoft Dynamics. We have telemetry systems where we get large volumes of data from like the truck behind us right there. And we also have laboratory systems where we do fluid analysis and oil samples. And all of those systems generate large volumes of data. So really over the last couple of years, we've been on a journey of consolidating that data into a single database platform, which is really about driving accessibility and visibility of that data, but also giving us the opportunity to analyze that data in ways that we haven't been able to do before and start to generate some insights into that data.
Oh, that's great. So what tools and platforms has Komatsu selected and why?
Yeah, so in terms of actually pulling the database together and building it, we selected Time Extender's Discovery Hub, partly because it's got a plug into Microsoft Dynamics, which makes it pretty easy to get data out of Dynamics, and partly because of its quite powerful data modeling tools, which really simplify that modeling process and allow us to, I guess, accelerate the development timeframes. From a database point of view, we selected Azure Managed Instance, and that was really a value proposition for us because our analysis showed that it was significantly cheaper than the platform that we were previously using, and also we anticipated some fairly good performance improvements in moving into that.
Perfect. So what sort of savings have you achieved at Komatsu by betting on managed instance?
Yeah, so we had a reduction in cost of 49% and an improvement in our ETL process of 25 to 30%. So really, from our point of view, that's pretty much a win-win.
Oh, that's fantastic. So what's next for you guys on this journey?
Well, I guess now that we've built a sustainable platform and infrastructure, it's really about how can we leverage that? How can we further tap into AI tools to help us with that deep dive and analysis on our data and hopefully find new relationships in that data that creates value for our customers.
Well, thank you so much, John. That's great to hear. It's great
Thank
to
you.
see you, MI working out for you. Thank you so much.
Yeah, cheers.
You know, hearing stories like that is basically what inspires all of us, and you know, and the product side, the marketing side, every function that works on the data platform to do more. Now, are you all ready for looking at the demo of hyperscale and how long it takes to restore a very, very large database? Let me invite Elaine to showcase how easy it is to migrate to MI and do some fun stuff with the large database.
Thanks, Rohan. Welcome, everyone, to Ignite. I'm really excited today to show you some of the fantastic innovation that we've done with Azure SQL Database over the last couple of months. But we understand that the journey to the cloud for all of our customers begins with migrations. So the first thing we're going to look at is migrating a database up and just show you how quick and easy that is. Here we've got an application that was built on top of SQL Server, and it took advantage of features like CLRs and linked servers and cross-database joins. And these were things that in SQL Database, prior to managed instances, we didn't have support for those. So we could never move this application up into Azure. So here, I have a database migration service that I've pre-configured for this demo. And all it basically requires is just a source database, a target database, and then sort of an intermediary storage, which is an Azure blob in this case. So I'm just going to kick off this migration job. And what's happening here is basically the database is being backed up locally. It's then being shipped across to the blob and being restored up into managed instances. And without having to change a single line of code, I can come and I can refresh my website here. And you'll see we've now flipped over to Azure SQL Database managed instance in this case, with all of the features that our customers know and love. So it's a fully managed service that'll give you the full surface area of SQL. But we also understand that our customers don't look after one database or two databases. Most of our customers have large fleets of databases that they have to manage on a daily basis. So with Azure SQL Analytics, for those customers that have chosen to move their SQL workloads up into Azure, we offer a single pane of glass where we give you all the insights into the performance of your database across subscriptions, across instances, across databases, all with a granularity of single queries. So if we dive a bit deeper into this, you'll see here we have a single subscription, but this can run across multiple subscriptions. You can have multiple managed instances that you monitor from one place. And here you see we have over 100 databases that we're looking at, and it's surfacing everything that's important for me to manage performance. So if I just dive a little bit deeper here, you'll see I can see exactly where this database is having performance issues, and I can dive into the individual query, and we will surface insights that use best practices and a lot of sort of pattern recognition in the back end to make you get the most performance out of your databases running in Azure. So with managed instances and data migration services, really easy for you to move up into the cloud. Managing that environment becomes just as easy. And now we're going to switch gears a little bit, and we're going to flip over to the demo that Rohan was referring to. So if I just leave that there, essentially the hyperscale service tier within Azure SQL Database, we re-architected Azure SQL Database from the ground up, separating compute from storage, and offering unprecedented support for very large databases in Azure. We now support up to 100 terabyte databases, but theoretically there is no upper limit to the size of the databases that we can now support within the Azure platform. So what I'm going to do here is I'm going to kick off a restore on this database. So if I had to ask everyone here to think of how long it would take them to run a restore of a 50 terabyte database in their current environment, that number would be hours, days, weeks in some cases. So what I'm going to do here is I'm going to literally restore this database to 24 hours ago, and I'm just going to kick off the query. So what's happening in the background here is that database is being fully restored. We're provisioning compute for that, and that database will be fully operational and online when that restore is complete. So if I come and show you here from the history, there you can see the restore job that's kicked off. Now I know how long this takes, so I ran one of these before I came out on stage today. And if you look here, we were able to restore a 50 terabyte database in 7 minutes and 44 seconds. And that's really the power of hyperscale. We've offered unprecedented support for customers that have huge databases without compromise on any performance. So this, plus the ease of management and the ease of moving to Azure, should give our customers the comfort to know that when developing on Azure SQL Database, they're developing on a platform that is future-proof and will continue innovating as they move into the future. Thank you very much, and back to Rohan.
Thank you, Elaine. That is fantastic to see. And again, when you look at the amount of innovation that sort of you're delivering as a part of modernize to the cloud, there's a lot of features that we've added, a lot of core capabilities, fundamental security. Again, you see the list on the screen. I'm not going to go through all of them, but it's really fantastic to see how this range is shaping up. Now, getting on to the third theme that I spoke about, building cloud-native apps. These are new cloud-native apps that just weren't possible before on-premises, where you truly need the global scale of the cloud. And our flagship database service here is Azure Cosmos DB. We announced this at Build last year, and the growth has been just phenomenal. The core foundations that have gone into building this service, essentially which doesn't allow you to choose between consistency and performance. Effectively, the core foundations that have gone into making sure that the resource governance, the global replication, the consistency models that are supported are so foundationally architected correctly is leading to the growth that we're seeing. It's been fantastic to see the kind of applications, very, very large NoSQL multimodal databases that are being built and serviced using Azure Cosmos DB. And I'm very, very excited to announce, as you heard Scott speak about this morning, two very, very critical capabilities based on the feedback we've heard from our customers: support for multi-master and the support for the Cassandra API. Now, what does it mean specifically? Multi-master replication is an extremely hard technical problem to go solve. This is something that the team has been working on for several years to actually perfect and get this right. There is no other service, no other cloud service in the world that supports the multi-master capabilities so natively the way we are launching this with Azure Cosmos DB. And it's actually fantastic to see how customers are adopting this. You're going to hear from one of them shortly. Cassandra API, with the product strategy we have of supporting multiple APIs, you saw we did that with Mongo, HBase, and others. We are adding Cassandra just given its popularity. And one of the key themes essentially is no changes to your application when you migrate your Cassandra app to Cosmos DB. With multi-master, we had 5 nines of availability for reads. You have that for writes now. You can basically make any region in the world that was only a read-only region prior to multi-master becomes a read and a write or an updatable region as well. That's how we significantly increased the availability guarantees we are giving on both reads and writes. 5 nines. There is no other service that has that. In terms of TCO, with the support for reserved instances, reserved capacity with Cosmos DB, you can save up to 65%. Again, this is the work that we did based on the feedback that we got from our customers. And finally, if you look at the lowest entry point, price point with which you can start off, we've reduced that by 5x. And we're going to enable linear growth from then on. Again, exactly responding to the feedback we were hearing from customers. So anyone who basically didn't want or wasn't trying out Cosmos DB based on price, that friction essentially has gone away now. And we're very, very excited to see what our customers do with it. Again, to learn about how customers leveraging Cassandra and the multi-master APIs, let me invite Michael from Symantec on stage to join me. Michael?
Thank you.
Thank you, Michael. So tell us about Symantec.
So Symantec, we are a global security leader. We are worldwide, and we are handling threats all over the place. We are delivering this for both consumer and enterprise in my group. I'm actually part of Norton Cloud Services, and what I'm going to talk about a little bit is Project Shasta, which is a code name for our file reputation, URL reputation, IP, and so on. Also our notification platform, which comes next. So these make up services that many are 1 billion plus query per day services. In all, we're talking about over 6 billion requests a day. There are surges against Cosmos that occur that are over 100,000 requests a second. Again, worldwide. It's not hitting one region, it's hitting 1, 2, 3, and soon to be 5. All of these services are driven by managed services. So we've got Cosmos in the stack, we've got Azure Redis in the stack, of course Event Hub on back for the telemetry pipeline, but then they have to be driven in a fully elastic environment, so it's based on VMSS.
Great. So can you tell us about the business priorities you're solving with the bet on Azure Cosmos DB?
Absolutely. The most important, actually, they hit on the keynote this morning, worldwide reputation response time. We need to be in the millisecond level. You've got kernel blocks. You've got attacks that are being shut down. We don't want to affect the user. We want those reputation queries to come back instantaneously, no matter where you live. So then, go ahead.
So, sorry, go ahead.
OK, second part. So the, oh, no. The second part was the notification platform. We need to be able to deliver notifications worldwide instantaneously within milliseconds, and Cosmos allows us to do that worldwide.
Perfect. So tell us about how you're using the newly launched Cassandra API and the multi-master capability with Cosmos DB.
Absolutely. First, Cassandra API, very important to us. Engineering effort was next to nothing to move our services. We took and we migrated our notification platform without making any code changes. Our engineers didn't have to sit there and rewrite code. So we were able to quickly move over. That's for both C++ and Java. Second, on the multi-master, really critical. I talked a lot about important services. They cannot go down. We've got millions to billions of keys in these services across multiple regions. We need to be able to seamlessly move traffic for maintenance. We need to be able to move it if a region goes down or for any number of other regions. So we need resilient infrastructure, and Cosmos gives us that along with the Cassandra API.
Perfect, perfect. It's great to see. Thank you so much, Michael, for sharing your experience with Azure Cosmos DB.
Thank you.
Great to see. Well, that was impressive. Just you saw like how multi-master and almost zero code changes with Cassandra are so critical for them to sort of migrate their existing applications. So let's actually see the capabilities around multi-master by inviting Deborah, who's a program manager in Cosmos DB, on stage. Deborah?
Cool.
Thank you.
Hi, everyone. Cool. All right, thanks, Rohan. With Cosmos DB's new multi-master capabilities, developers can write planet-scale applications where not only can your app read from the nearest Azure data region, it can also write to that region as well. So let's see Cosmos DB and multi-master in action. Here, I have an application our team has built called PXDraw. It's a collaborative drawing experiment where users from all over the world can come in, choose their favorite color, and draw on this canvas. Now, I have this app deployed behind an Azure Traffic Manager, with one side pointing to the replica in West US and the other in Japan West. You'll see that as I choose a color and start drawing on this canvas, my updates are being written to Cosmos DB and propagated in almost near real time. Pretty cool, huh? All right. Yep. And to truly show the benefits of multi-master, if I go over to my Japan West replica, I can go over here, complete my smiley face, and see again, the data is written all the way to the other side of the world. Yep. All right. So now let's take a look at how Cosmos DB makes this all possible. First, I'll navigate to my Data Explorer, which is my one-stop shop for viewing all the data in my Cosmos DB collections. I'll use a new feature to view this view in full screen, which we shipped over this summer. And in full screen, I navigate to my board and see that in this collection, each pixel is actually stored as an XY coordinate along with a color. So that's how the data is stored. But what about the global distribution? With Cosmos DB's turnkey global distribution, adding a new region is as easy as clicking on the region on this world map, hitting save. And that's it. The data is now being automatically and asynchronously replicated in the background. And when this region comes online, it will be a right region in its own right. Now, the important thing to note here is as this is happening, my application is still highly available. In fact, with multi-master, we now get not only 5 nines of read availability, but 5 nines of write availability as well. Additionally, we've updated our SLAs to guarantee a less than 10 millisecond latency for both reads and writes. That's single-digit millisecond latency for both reads and writes. Now, in other database systems that offer such high availability, they usually force you to trade off with consistency. Most other database systems force you to choose between strong and eventual. But with Cosmos DB, we offer 5 different consistency levels with click stops in between, so developers can come and make the right intuitive trade-off for their application. Again, it's as easy as going to the portal, picking the right one, and hitting save. Now, finally, in a system with running multi-master at scale, it's possible, rare, but possible, that conflicts can occur. For example, I might be trying to draw to the same exact pixel as someone else somewhere else in the world. In other database systems, conflict management is hard. Developers have to write custom code, be aware of the multi-master protocol, and this adds a lot of overhead. We want to make this easy in Cosmos DB. Today, with multi-master, we support 2 different modes of automatic conflict resolution. The first is last write wins, based on the latest timestamp or a user-provided property. But for developers who want more flexibility, we also offer the ability to write your own custom SOAR procedure, which Cosmos DB will automatically run on your behalf to resolve a conflict. This now means that one of the hardest parts about running multi-master at scale is now taken care of by the Cosmos DB service. So in conclusion, with Cosmos DB's new multi-master capabilities, you can now write planet-scale applications that can read and write to any Azure data region, all with single-digit millisecond latency. We are so excited to see what you will build with Cosmos DB. Thank you.
Thank you, Deborah. That was an amazing demo. To see multi-master in action like that, pretty amazing. Again, if you look at the amount of innovation that's happening in Cosmos DB, get the list of the slides. We'll definitely share this out. Not going through all of them, but it's fantastic to see how the service is growing and coming together. Moving on to the 4th pillar that we have around unlocking insights. The first thing I want to talk about is what we call the modern data warehouse pattern, and just share some of the learnings we are getting from our customers as they're modernizing their existing enterprise data warehouses to the cloud. Right? This pattern essentially consists of flexible data sources. Either it's coming from your traditional systems around CRM or ERP, IoT data that's coming from machines that's getting generated. The first part is essentially enabling scalable ingestion of this data. How quickly just basically you're able to pipe the data through. The second stage, essentially, is being able to store the data. I mean, you're talking about very, very large volumes of data in an economical way. The third stage in the pipeline is essentially being able to prep the data. Once you get unstructured data, semi-structured data, before you can start doing some meaningful queries on them or building machine learning models, you have to clear and prepare the data. And then finally, serve data either using a warehouse or score using some machine learning models. And finally, visualize using tools like Power BI. Now, for each of these, we've essentially invested in creating world-class capabilities to ensure that the modern data warehouse pattern works end-to-end very well. With ADF V2 that we recently made generally available, we have 70-plus connectors, and we keep on adding to them. It's very cost-effective to store the data in Azure Data Lake Storage Gen 2 that we recently launched, bringing the best of ADLS and Azure Blobs together. With Azure Databricks, we have the best service in the world to prepare your data using the best Spark that's available out there. With the work that we've done on the Gen 2 of the Azure SQL Data Warehouse, which we again launched recently and made it generally available, and the work that we did for the native data movement capabilities that we added, we are 2 times faster and 2 times cheaper than our competition across the lake, if you will, from where we live. right? And it's actually fantastic to see how the deep integration that we've built across all these services is really working very well for our customers. It's not just about having these capabilities, but the ability to stitch them together in a very simple way when you think about things like security. How does this work? Now, let me go back to what we just did with SQL Server 2019 for a second. Now you're able to manage your entire big data cluster using SQL. And let me touch on the hybrid capability for a bit. This is a very clear example when you think about the innovation that we've done in SQL Server 2019. It is also based on what we've learned from our customers in the cloud. So the same customers look at the abilities over there and say, look, you're creating all this value. Why can't I use SQL to do the same thing on-prem? And that's really what guided our investments. So when you think about hybrid, think about how unlocking analytics in the cloud and unlocking analytics in the on-prem is being stitched together in a very, very seamless way. That's a core part of our strategy. Now, to learn more about how one of our big customers, ABI, is using this modern data warehouse pattern, let me invite Chetan on stage. Chetan?
Hey, Rohan.
Thank you so much for coming over.
Absolutely.
So tell us about ABI.
Well, AB InBev is a global brewer. We have over 500 plus brands. We operate in 6 different geos across 50 plus countries. Some of our brands include Budweiser, Stella Artois, Corona, to name a few. So our scale is large.
Perfect. So how is ABI using Azure for analytics?
So in Azure, we're building a global data lake that's powered by SQL Data Warehouse and Azure Data Lake Store, where we can orchestrate data science VMs and Spark clusters. So using this tech stack, our data scientists are looking for patterns to optimize price and promotions. Additionally, they're looking at additional sources of customer data so that we can identify customer preference, and not just customer preference when it comes to beer, but also beer plus food correlations.
Who knew? Tell us about appliance migration. What are the benefits of moving to the modern data warehouse pattern that I just described?
Given our complexity, our data used to be very siloed, given that we ran in 50 plus countries in multiple data centers. Adopting SQL Data Warehouse is giving us a lot of agility. And as we started bringing all of our data into a consolidated data lake, it also gives us on-demand scalability, which is very key. We recently moved a 35 terabyte on-premise legacy virtual appliance into Azure, and we're seeing very stable performance.
Oh, that's fantastic to hear. So what are the reasons for adopting SQL DW?
One of the big reasons is a familiar SQL environment. It's helped us tremendously on the adoption curve. Our data engineers are able to work with the product very easily. And this is very important for us, because given our scale, we're looking at moving petabytes of data into our data lake, especially as we move data from supply and breweries. So having a familiar environment helps us on that adoption curve.
Oh, that's fantastic. So what's next for ABI and Azure?
So we're about halfway through our goal of running 80% of workloads in cloud. The next couple of years, we'll see accelerated data movement from our functions into the data lake that we have. And finally, we're also evolving our analytics platform, where we're looking to adopt Azure Databricks to further accelerate our analytics function.
Oh, that's fantastic. Well, thank you so much for sharing your insights on how you're using our modern data warehouse pattern. So next time when you're enjoying a good, nice cold beer, remember a lot of the analytics that's backing the making that better is happening on Azure. That's fantastic. The one thing, again, you heard Scott talk about a new service that we are launching called Azure Data Explorer. We're launching this in preview. Let me tell you a little bit of history behind how this service came about. As we started building a lot of our cloud services, the amount of telemetry data that's coming from Office 365 or Xbox Live or Azure itself, all of Windows client telemetry, there was no tool in the world that actually enabled our engineers to look at the operational data that was coming out of these services to debug, monitor the systems in real time. That's when internally we sort of started working on the service, which is being released now as Azure Data Explorer, for extremely fast ingestion. So think about very low latency ingestion and very low latency analytics with regards to just exploring the data, right? And there was a lot of emphasis that we placed on textual analytics. This was an area that was weak in a lot of the systems that we saw. And it's fascinating to see most of Microsoft Cloud services essentially run on this service, right? So when you think about millisecond level ingestion, analytics that are happening at significantly high scale, it's actually beautiful to see. This is a gap that we saw that existed in the industry. It's basically a gap that exists in the pattern that I described. So even before you get into the prep phase of data, you need to explore the data and do interesting queries on it to see which proportion of the data set is actually valuable to you. And the team has done a fantastic job of making it really simple based on the query language that they've shipped, the tooling integration that they've done, the ability to scale up and scale down very, very quickly across hundreds of machines. So the best way to actually see this is, again, through a demo. So let me invite Evgeny, who's a program manager on the team, on stage to showcase this brilliant new service that I'm very excited about. Evgeny, take it away.
Thanks very much, Rohan. Hi, everyone. Thank you. So those of you who were at Scott's demo this morning also got to see the introduction for Azure Data Explorer. Today, I'm actually going to dive right into some queries. So as Rohan mentioned, this is queries over a huge volume of data with very low latency. So let's take a look at this data set that we'll be looking at today. This is actually Power BI's telemetry. So Power BI was one of the very first services to adopt Azure Data Explorer internally, and so we'll be looking back at some of their logs here. Now, this data size is a little bigger than the one that I showed at Scott's demo. There we are. Sorry, screen went black for a second there. But we've got close to 30 terabytes worth of data in this data set. The biggest table is 20 terabytes. So if we take a look at that biggest table, I joked at Scott's demo about 1 billion records being a small data size. This one's a little bigger. Let's take a look at what it is. Actually, this one's closer to 41 billion records. So let's do some queries against that, see what happens. So the very first thing I might want to do is to look at my error logs and try to figure out and aggregate by the error level. How many errors am I having per error level? So I'll run this next query, and we get data back. This is just a day's worth of data, but you can see that regardless. And of course, if you didn't get to see it previously, we've got visualizations here too. So I can go and visualize this as, let's say, a bar chart. And this essentially, because of the analytical nature of the tool, lets me not have to shift my focus into another visualization tool. I can detect my patterns right here, as we'll see in a little bit. Now, OK, let's pick out the level 2s and take a look at some of the data in here, right? So we can see we have standard date time, we have strings, we have numerals. And so you can store all sorts of data, including completely unstructured data, such as this event text over here. You can see just how big some of these blobs are. And we can query across all of it and get results back just as quickly. I also mentioned that we have support for dynamics, and that still continues to be true over here. Now, if we take a look at the role column over there, there's actually 2 pieces of information here. There's actually the role name, as well as the ID of the particular instance of the role. So what I'm going to do is just pull that out and start doing some aggregations to try and figure out whether any one of my roles is running particularly hot. And you can see right away 2 pieces of insight here. You can see that there's a big spike over here, but more so that one of the roles is consistently running hot. And so right away in, 600 milliseconds there, I was able to go filter down to a particular set of data, in this case, a particular class of machine, and get insights from it. So we could certainly continue down this path of analysis, but what I want to do is actually shift over and look at my most frustrated user. So I'm going to be doing a bunch of things over here. I'm going to be defining inline queries. I'm going to be defining constants. I'm going to be doing joins. I'm going to be doing aggregations. This is a full-fledged data platform. You have all of these different operators available to you. This isn't just aggregation and filtering. So let's run this query, and this is actually, I guess I already did, but this is going to pick out my most frustrated users. And you can see that there's 2 over here with 2,000 errors and 1,500 errors that are running particularly hot. So let's see what errors this user, the 3309 one, is running into. And again, I'm doing all sorts of filtering, all sorts of complex joins, things like that. And we can see right away that we have top 2 errors. Now, one other type of data that Azure Data Explorer is really good at, amongst many, is time series data. And in this case, I'm looking at just some basic perf stats. So, we've got a date time, we've got a role, and we've got the value. And so this is going to be by far the longest query I run today. What it's going to do is it's actually going to look for a particular shape, which is a step function, so something that was low and then all of a sudden went high. And out of thousands of data series, I was able to pick out 6 that correspond to this pattern in just 5.7 seconds across all of this data set. So again, just some examples of the power of Azure Data Explorer. Come talk to us at our booth. We'd love to show you more. But with that, back to you, Rohan.
Thank you so much, Evgeny. That was great to see. I hope you guys got a glimpse of it. It's fantastic. Please try it out and give us feedback. Bringing it together with HD Insight, which is the service that we have in Azure for managed Hadoop workloads. We're very excited to announce that Azure will be the first cloud platform in the world to natively support Hadoop 3.0. We are bringing that as a part of the Ignite launch. A couple of areas of feedback we heard from our customers as we started getting into the managed Hadoop space was enterprise security. They basically wanted the same security with Azure Active Directory extended to the HD Insight clusters. They basically wanted the native way in which Hadoop clusters get more secure using tools like Ranger, et cetera, work very natively as well. So we've invested very heavily in that, and I'm very excited to announce that a lot of these features that I spoke about are available today with HD Insight. And finally, as developers have used our platform, one of the things that they've told us is it's hard to debug very, very large-scale Hadoop systems. Internally, we actually been investing in a lot of these capabilities managing our own big data clusters, and we are bringing that to bear. All the learnings that we captured in our own dev experience now are available to all the developers using HD Insight. Very, very excited about that. Again, wrapping up this section, there's a whole slew of features. Again, I'm not going to go through each one of them, just to give you a sense of the innovation that's happening in the unlock analytics area. Moving on to machine learning, one of my favorite topics. There are basically 3 areas of investments that we have. You've heard us talk about the bot platform that we're building with intelligent agents, et cetera, which you can just embed in your applications. You've heard us speak about the investments we're making in knowledge mining and cognitive search, which again, you can deeply embed and create amazingly new scenarios. The thing that I'm the most excited about being a data platform person, of course, is machine learning that's deeply integrated with our data services. And the key service that we've sort of launched earlier this year in Azure Databricks coupled with machine learning that I'm really excited about. It's growing very well. We're seeing significant amount of customer adoption, basically getting the best of Spark that's available in the world as a first-party service on Azure. The response has been amazing. And let me basically go ahead and actually invite Ali Gotzi, who's the CEO of Azure Databricks, somebody that I've partnered with very, very closely on stage, to come and have a chat with me. Ali? Thank you for coming, Ali. Really appreciate it.
Thank you.
We're super excited about how this partnership is going and just the phenomenal growth that we're seeing with Azure Databricks. When do you want to share some thoughts?
Yeah, I mean, it's been absolutely fantastic. In 2 quarters, we've seen over 1,000 customers globally, and in many different industries too. Really exciting. I mean, we've seen them in retail, in mass media, fintech, but my favorite is healthcare because, those are the most aspirational use cases, so it's very, very exciting.
That's fantastic to see. That's amazing customer traction. Why do you think the customers are adopting this so quickly?
That's a great question. I think really what it has to do with is that Azure Databricks actually gets to the core of what is blocking most enterprises when they want to achieve AI projects. So most enterprises now want to have AI, but the key to getting to that success is really the data. You have to get to the data. And what large organizations have done is that IT owns the data lakes sit there, and they have their own systems and maybe their own technologies. And then line of business oftentimes has the data scientists that are actually doing the machine learning, the AI, and they need access to the data that sits in AI, in the IT system. So you have to combine the two. So Azure Databricks, what it does is that it unifies these two. So it's a unified analytics platform that brings these two together. So you can use the same languages, you can support all the different technologies that they need to do different sides, and that's really unblocking them, and that's why we're seeing this taking off so crazy.
That makes a lot of sense. Thank you for sharing that. So what are the new, this service is just growing so fast. I'm so excited. So what are the new product innovations that you are excited about?
Yeah, so we started looking into this, unifying these two, the basically data and the AI, and what we saw is that oftentimes now enterprises have collected a lot of data into their data lakes, and that's awesome because that data is valuable. But AI is sometimes an afterthought. So they're hoping that later on they're going to apply AI on top of this data. But what might happen later on is that that data might not have the right quality, or it might not have the right schema, and it might not have the right performance either. So you might run into trouble. So as a result of this, we're super excited to actually today announce Azure Databricks Delta. Azure Databricks Delta actually has a preview, so you can actually go start using it today. And what you can do with Azure Databricks Delta is that you can actually situate it on top of your data lake, and it then adds things like transactions, things like performance, and you can raise the quality of your data so that you can actually, later on when you're doing AI, that data is just ready for that AI. So it's super exciting. Please try it out.
It's basically preparing the data for eventually going to it.
Yep.
Any surprises? As you've sort of been on this and what you've learned with Azure Databricks and being a part of Azure?
Yeah, that's a great question. Yeah, I would say the biggest surprise I've seen is how actually this was, we weren't even expecting this. The way they're combining Azure SQL Data Warehouse with Azure Databricks, that has been actually really exciting. So basically what they're doing is they're building a modern data warehouse. And what that means is that they're going beyond what they could have done just with Azure Databricks or what they could have just done with Azure SQL Data Warehouse. By combining the two, now they can deal with all kinds of data, structured, unstructured, semi-structured. They can do it in real time. They can do machine learning on it. They can do SQL on it. So that's really exciting. And as you know, we're working together to actually really make these two products completely integrated so that you can have really a native experience going back and forth between them.
Perfect. No, I think that integration is going to be key, as we heard from our customers. Thank you so much, Ali. I really appreciate you.
Thank you so much. Yeah.
Thank you. Again, fantastic, and it's great to see the investments that Ali and team are making in combination with the Azure Data Organization to build the modern data warehouse pattern together. Now let's actually talk to one of the customers who's betting big on Azure when it comes to machine learning and AI. Let me invite Daniel, who's the general manager of Shell. Daniel? How are you? Thank you for joining us. Can you tell us a little bit about Shell's solution?
So, as you heard this morning, Shell is the largest single-branded retailer on the planet. We run about 44,000 gas stations. We operate in about 70 global markets, and we've got around 30 million customers every day. And when you're operating a business at that scale, safety and security is the #1 priority. What we saw with machine vision was the opportunity to provide the service champion, that's the person serving the customer at the station, with what they need to have a second pair of eyes observing potentially high-risk incidents. And so we brought together the IoT Hub with Azure Databricks and the Intelligent Edge to provide a real-time alerting solution. And we've now deployed that into 2 pilot sites in Thailand and in Singapore.
Oh, fantastic. That's pretty impressive. How are you using Azure Databricks?
So we're using it in 2 ways. Firstly, we're developing our own models in-house, and we're then leveraging the combination of TensorFlow and Databricks to train those models. But we're also using Kafka and Spark Streaming to allow us to run tight processing. What I mean by that is we're able to combine the models at the edge with the models running in the cloud to provide a filtering solution at the edge with a verification solution in the cloud and ensure that we reduce the number of false positives that we give to the service champions.
Fantastic. So what was so important to deploy the solution on the edge?
So if you think about this scenario, it's about safety. And what's really important about safety is making sure that it's a real-time solution. Because if we provide any sort of latency, it limits the amount of chance that the service champion has to intervene. So in this scenario, you're talking about 6 HD cameras at every retail store. That's about 200 megabytes per second. And it's not really affordable or practical to pass that sort of data volume into the cloud. So what we were looking for was a solution that allowed us to combine the edge processing with also the cloud-based processing in a seamless way. And we were extremely impressed when we compared the offer that Azure had with other providers, because the latency was just absolutely minimal. And that was really fantastic and really differentiating for us.
That's really great to hear. So how do you foresee the solution expanding in other parts of Shell?
So we're an extremely physical company. We operate a very physical value chain from platforms and refineries through to pipelines and wind farms. And if you think about those businesses, we make observations every day, and all of those observations could potentially be automated through machine vision in some way. And what we see is the ability for machine vision to augment our existing staff and help them in their day-to-day jobs. That means things like observing the early onset of corrosion, or perhaps looking at stock levels in a new way, or alternatively, even looking at things like truck movements in capital project sites. And what's extremely exciting is how generic the solution we've developed is. It allows us to take our in-house developed proprietary algorithms and combine it in such a way that it can actually be deployed at scale very, very quickly. And that's extraordinarily exciting for us. It means that we've got a solution which we can roll out right across our business and leverage our knowledge of our own business at scale.
Man, I'm getting excited just hearing you speak like that. That's awesome. Thank you so much, Daniel. That's amazing to hear the story of Shell. Thank you. All right, that's a fantastic story. So let's actually see through a demo how all that stuff that Daniel and Ali described come to life. Please join me in inviting Deepsha on stage to showcase the demo, this real use case of Shell. Thank you.
Thank you, Rohan. I'm going to show you a simplified version of the sorts of things that Shell is doing for the purpose of this demo. The dashboard that you see up there, there it is a view that Shell intends to roll out as a part of its ongoing pilot throughout their retail site managers. So retail site managers need alerts to keep their gas station safe. Alerts like unaccompanied minor, a tripping hazard, a blocked exit, or something that can be as fatal as someone smoking a cigarette near a gas pump. So note that these recent alerts that you're seeing here, they're predictive alerts. So let's see how that predictive model was built. I'm going to go to my Azure Databricks notebook. So the first step in any machine learning model is to bring data in to train your model. So Dan, who you saw speaking earlier, I checked with him, but he said burning down a gas station and taking selfies with it is not the right way to collect data. So because we listen to our customers, with Azure Databricks and MML Spark, we make it extremely easy for you to search through the internet. In this case, I'm going to do Bing search for my keyword-centric images and data, like something of a dangerous image of a gas station. So we have these images, or a keyword-centric search for normal images in a gas station. And there I have it. That's how easy it is to do within Azure Databricks. Now that I have my data set, the next step is image classification. So for image classification, doing deep learning can be extremely time-consuming and complex process. With Azure Databricks and MML Spark, we enable you to do deep learning through transfer learning on pre-existing model. In this case, I'm going to do transfer learning on ResNet 50. This enables you to not have to train your models from scratch, but to leverage other models and build on top of it to fine-tune for your specific scenarios. And then you can use the power of distributed processing on Azure Databricks to really reduce your time to insights. But to really get to the near real-time insight detection, you need to deploy your model as a next step to the edge itself. In this case, that's this Vision AI camera that is looking for incidents at the gas station. Azure Machine Learning Service comes to the rescue. It enables you to easily containerize your model and deploy it to the edge device or to Kubernetes cluster if you want. But now that I can deploy it to the edge, my camera is intelligent to be able to detect an incident at a gas station. Now that I've covered all the bases, let's go ahead and see what happens. So here's my dashboard, and I'm going to bring up a cigarette. I'm obliged to say that this is not a real cigarette, and this is not an endorsement of smoking. So what happens when I put the cigarette in front of the camera? So let's see. Oh, so it looks like I received a safety alert because it detected a cigarette near me. Now let's see what it is really detecting. So it's not only detecting danger, it's telling me the confidence level of how dangerous it is. I have the option to quickly go here and stop the pump, and I can enable that through event triggers as well. And come back here, you see the alerts increase to 65. That's how you build data science from intelligent cloud to the edge using Azure tools and Azure services. What we saw was bringing in data easily from the internet, doing transfer learning on distributed processing, and then ultimately deploying your model to the edge, and then allowing your retail site managers to detect and take action. That's the power of Spark. I hope you go back and try it. Now let me hand it back to Rohan.
Thank you, Deepsha. That is fantastic to see the real-time detection and alerts coming in. So finally, we started off with the 4 themes that we're hearing from our customers and how the innovation that we are doing inside Azure and SQL Server is lining up to each of these themes in a very, very meaningful and substantial way. I hope you got a little bit of glimpse of that. The data platform that we're building, the insights, and how we're making that easy by essentially infusing AI into all aspects of our data platform. And hybrid being the key principle that drives this set of innovations. My buddy JG, who leads product marketing for all of data and AI, sort of reflect on this a lot, where we are at a very interesting time. One of the things that inspires us to come into work every day is to see the kind of transformations that you can do in each of your enterprises as you're fundamentally shifting the way you operate your business, the way you're serving your customers. And it's an honor for us to be a part of that journey, supporting you and backing you all the way. Thank you so much, and I hope you guys have a great Ignite.